Okay, so this is on page 1. It says all of the properties for parallelograms. And then on page 2, we wrote in that consecutive angles are supplementary. That's the third property. And then you just subtract from 180. Okay, this one, super easy. Opposite sides are equal or congruent, which is the same thing. It's just somebody decided that for shapes you need to have a different word than equal. I don't really know why. But it's the same thing. They're congruent. So essentially what that means is that NK is just going to be the same as the opposite side, 15.8. But it's that property that shows us that. So it's just important that you know where these things are coming from so that you can replicate it later and do it later. All right, now we have these angles, and we know that opposite angles are congruent. Hopefully we know that. If you don't know that, well, we just learned it today. So opposite angles are congruent. And when I say opposite, I mean they're just on opposite sides of the shape. D is over here, F is over here. They're not, next to each other. So we can just set them equal. Essentially, today is more of what we've been doing all year long. You either set things equal or you add them up to 180. It's pretty much the same thing we've been doing all year. I'm going to subtract 21x on both sides, so negative x equals negative 4. Right, we don't care about negative x. We want to know, positive x. So divide by negative 1 on both sides. And x is going to be 4. But make sure you pay attention to this as well, because, if it's a Canvas assignment or a Delta Math assignment or a test, if it asks for f and you just solve for x, you're not going to get the points for it. So angle F is 20 times 4. Yep, so it's just going to be 80 degrees. Beautiful. Let's move on. This today is pretty easy, in my opinion. We know that opposite sides are congruent. So opposite sides congruent. But this one is a little more challenging because you can't just say, oh, 4x equals y. I mean, I guess you could, but then you'd have to use systems of equations if you have two variables, and let's get real, nobody wants to do that. But what you could do is solve for x first, because these sides are congruent as well as these sides. So you could just set these two equal. X plus 18 equals 3x minus 2. And solve for x and then plug it in, which is what we're going to do here. So I'm going to subtract x on both sides, but I'm also going to add 2 just to, speed up the process. 20. So I added 2 on both sides. Got rid of the x. 18 plus 2 is 20. 3 minus 1 is 2. So divide by 2. Divide by 2. X is 10. So I went a little fast there, but ultimately what I did was I set those equal because they're opposite. And then I know what x is. So I can take 10 and I could plug it in right there. 4 times 10 is 40. Perfect. Y equals 40, and that's it. So there's a couple of these on the Canvas assignment where it gives you multiple variables, and you just have to figure out which variable can I solve first, plug it in, and solve for the next one. So I'm going to pause for a second. I want you guys to solve for number 5 using that same idea. Okay, so 21.5, and as I was walking around, for the most part, people got this one. For the most part. This one was a little more of a struggle. See where 83 came from? I just plugged that in, set it equal to 83. You're not dividing 83 by 5. You actually have to multiply it, because we need to do the opposite of dividing. It's y divided by 5. We want to make it times 5 on both sides in order to get rid of the divided by 5. So it just becomes this really big number, 415. And then here, so I want to show you something. This is the first one we've seen about this property. The very last one, number 4. Diagonals bisect each other. All right, the diagonals cut each other in half. And again, we are still talking about the word bisect. It never goes away, literally every chapter. So you don't have to have these highlighters. I am just going to show you guys, they cut each other in half, therefore this one's equal to that one, this one's equal to that one. But it's not like the yellow and the orange are equal to each other. But 5y minus 16 can equal 3y. And then 2x plus 10 can equal 4x minus 2. So you can just like solve for them separately. If I subtract 5y on both sides, I get negative 16 equals negative 2y. Divide by negative 2. 8 equals y. And then for this one, if I subtract 2x on both sides, 10 equals 2x minus 2. And then I add 2. 12 equals 2x. Then you get x equals 6. So I solved that pretty quickly. But the main thing that you should know, like the geometry, the new stuff, is the fact that the diagonals can be set equal to each other. Like they cut each other in half. So each half of the diagonal can be set equal to solve. All right. Ooh. Perfect. Perfect timing. Let's do this real quick. Things that we know. The diagonals bisect each other. So even before I read these over here, I'm just going to like write these in. If this one's 14, so is that one. If this one's 20.7, so is that one, because they cut each other in half. But like notice like one's longer than the other. So this one's not equal to that one, but the opposite ones are equal. All right, and then opposite sides are congruent. So like this one's 24 and so is that. That's 26 and so is that. And so we can look over here now and we have all our answers. So PO is 24. OQ is 14. Where is this coming from? It's just coming from here. NO is 26. Okay, the angles are a little weird though. So pay attention as I talk about the angles. NOP. Okay, this is the weirdness. For one, 68 is like this entire angle. It has an arrow pointed to the middle, but it's the whole thing is 68. So that's what's confusing. Yeah, well, I don't know. I think that marking is just there to show that it's the entire angle. It doesn't actually specifically ask for each set of those. It's a weird picture. But the whole thing's 68, and then this angle right here and this angle right here are consecutive angles. All right? So 180 minus 68 is going to equal this NOP, this angle down here. And why is that? Because consecutive angles are supplementary. So NOP equals, what is that, 112, I think? All right. So we have 112 for this angle down here. OPM is this one down here. So like this whole side over here is OPM. Well, if this one's 68, that one's going to be the same thing. They're both going to be 68 because opposite angles are congruent. All right, and then this is the last thing we're going to talk about. So if you've stopped listening, this is important because this is typically what people miss. If they miss something on parallelograms, it's 100%, it's like basically this. This angle right here, NMO, is what we're looking for. So I'm going to put a little question mark there. Here's what you need to know. Parallel lines, transversal that runs through here. These are alternate interior angles. No, they don't go away. They just keep appearing. So this is 59. This is also 59, and the fact that they're alternate interior angles is the only way that you can tell, like, what this one is, unless you have, like, these other angles, okay? So that alternate interior angles thing, a lot of people miss that. Make sure you pay attention to that.